Okay, very good. Yeah, so last week we started to build our enterprise network topology. So just a simple network topology to explain networking. So before now, we've designed a simple LAN, but now we're designing a WAN. So this is a WAN. The Lagos branch is a LAN. The Abuja branch is a LAN. So connecting both of them, it will now become a WAN. So far so good. We've deployed access points. We've deployed layer 2 switches. We've connected the laptops to the access points. Last time I explained what an access point is, so I think we're all clear on that. Then I've configured the HR laptop one, the HR PC one, and the finance laptop one. So there's something I want to show us today, something very important that we are going to do when we configure the branch switch. I showed us this console port the last time, right? So we're going to configure that switch using the console cable. We're going to configure it in today's lab. So hang in there for it. So I also did a simulation under simulation mode to check all the packets. So you can just do that again to see where we are in our network. But let's even check if our switch is alive. So I think show MAC address. I think is the command. Yep. So I think our switch is still alive. So we can just quickly just see what's going on in the network. So let's ping. Let's ping. Let's just ping 192.168.10.3. Okay, so I think this is the access point. Access point takes it to the switch. Switch should take it back to the access point. So broadcast so that we learn the MAC addresses. Then HRPC, the destination replies to the back to the switch falls to the access points. Access point sent it to the marketing PC to finance LP2. So I think our network is good to go. If you didn't understand that, check the first video on the YouTube channel. Okay, so let's configure more devices. All right, so what am I doing? So yeah, so 192.168.10.6. Then so typically, in the real world setting here, if you want to configure this IP address, this is where you go to. So let's quickly do that. So you go to your control panel. You can see my screen, right? Yeah, so you go to your control panel, you go to network and sharing center, right? So you change adapter settings. Click on this to list all your adapters. So I have one for VMware, I have another one for VirtualBox. So this is my main adapter. So if you click on it, double click on it, you will see configure. So you go to, this Internet Protocol version 4, click on it. So this is where you are going to configure IP addresses. So This in the real world setting here, this is where you go to. You know, if you want to use DHCP, you click this. But I've configured this to use this, right? You can click on advanced settings, configure DNS, my DNS server, you know. So that is where you go to in the real world. So I just wanted to show us that so we get it. So coming back to my PC, so our gateway is 10.1. So we've configured that. Marketing PC, then make it 10. Let's copy this. So marketing PC2, desktop, command, sorry, ipconfig 10.7. Okay. So configure marketing PC. Let's configure this to be 10.8. Then default gateway, make it 10.1. Yeah. So in the real world, you're going to go into all these devices and you're going to configure them one by one, especially when you're not using the DHCP software. So you have to configure them one by one. So this will be 10.9. Then you go to this, 10.10. Right. This will be 10.11. That's 11. This should be 10.12. So we use this laptop. So let me show something real quick. So we use this laptop to configure. Let's configure the switch. So you go to RS-232. So you will know what an RS-232 port is. Just that you might not know that that is the thing. So it's a common port and a common cable. So if you check the RS-232 cable, what's wrong? Oh, okay. Google wants to know if I'm a robot. So we've all seen this cable before, right? We've seen this cable before, right? Yeah, so this is an RS-232 cable. This mouse you see here is an RS-232 cable. You know, so this is what you connect to on this laptop. So I'm connecting from this to the switch. So I'm gonna click on console. So we're using Nene's laptop to configure this switch. So if you come to Nene's laptop now, this is how it is in the real world, right? So in the real world, you would have thought that you would get a console cable. So it could be an RJ45 cable, it could be an RS-232 cable, it could be a USB cable depending on the console port. So you plug it to the console port. So if you check this switch, put the physical and we zoom in, you should see a console. So this console is used for management. A console port is typically used for management. So you connect to this port, then you connect to your laptop. Ideally, when you connect to your laptop, you open PuTTY, right? And you can, there are two major ways you can use PuTTY to connect to configure the device. Since your laptop is connected to the switch, you can enter the IP address of the switch and um, connect to it via PuTTY. And you can also connect through the USB, ports. Okay, so if I go to your device manager, open device manager, and you open ports. So if I'm connected to the switch on a port, it will tell me the port here. So you can see COM3, right? So if I select this, depending on the COM, if it's 3, this speed, note this speed, 9600, you will soon see it. I can connect that way instead of using IP address and then open and have my connection, right? So let's go back to this. So on my laptop, that's where the PuTTY is, right? PuTTY is on my laptop. So you go to terminal. What are you seeing here? 9600. So Cisco Packet Tracer has taken into account, what can happen in the real world, right? So you click OK. Now see what's going on. From the Nene's laptop, I can access the switch. Can you see? Are we clear on what I just did? So instead of clicking the switch and going to the CLI, I can configure the switch from a laptop, just as I would do it in the real world. Actually, in the real world, you configure the switch through an administrator's PC, not that you now just enter the switch just like that. You have to connect to it. So is it clear so far? What I've done, is it clear so far? I need our feedback. Is it clear so far?
Yeah, it's clear.
Okay. Nene, is it clear? Nene, is it clear?
No, really. Can you go back to PuTTY? What you did on PuTTY?
Okay. So in the real world, yeah, you need to configure a switch in the real world. You will need to carry your laptop, an administrative laptop. You need to carry your laptop, get a cable, plug it to your laptop, then plug it to your switch, just as we have here, right? I'm connecting the cable to the laptop and then to the switch. So when you connect to the switch, there are 3 different ways you can, depending on the device and the maker. You can configure that cable. So when you connect the cable to the switch on your network, you will see a network here with the name Ethernet, right? ETHERNET. So you click on it and you configure a static IP address to it. So for example, I configured a firewall recently, and the IP address I was told to log into that firewall to configure it was a particular IP address, right? So what I did was I when I connected through the console cable, I opened the network properties and I typed in an IP address. I gave an IP address to my laptop that was in the same network as the IP address that they specified. So the IP address they specified was like, I think 10.0.0.1. So I gave my laptop an IP address of 10.0.0.2, same network. So the 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 firewall and my laptop were in the same network, right? So what I did was to then open my Chrome, right? If I open my Edge, you should still see it. I think I removed it. So I let me see if 10 dots. Yeah, this was the IP address. So I was connected to the firewall, right? And I now open this IP address, this management IP address. So I could open it because I was connected by means of a cable. Now, this website will not go simply because I'm not connected to it. So it cannot go. But if I connect to a cable, it is going to open up the page, right? So you can begin to configure the device by virtue of opening a page on Chrome. So that's one way. But most of the time, you have to configure it through a CLI. So this is using a graphic user interface, right? So you have to configure it through a CLI, and that's where PuTTY comes in. So you would open PuTTY. PuTTY gives you remote access into a device. So ideally, the switch, you can give the switch an IP address. So let me just do it here. So you can give the switch an IP address. So let me open your laptop. This is Nene's laptop. So I'm in the switch, right? So I can do configure terminal. So I enter global exec mode. Now, if you want to give a switch an IP address, now a switch, a layer 2 switch, does not need an IP address to function. So you only give it an IP address when you want to configure the switch through maybe PuTTY, right? So it's for management purposes. The IP address is simply for management purposes because typically layer 2 switches don't need an IP address. So you can give this an IP address. So for you to configure a switch, a layer 2 switch, you do it using their switch virtual interface. So let me quickly show us what that is. So if I do show IP interface brief, so you're going to see all the interfaces of this switch, right? So you can see fast internet 0/1 to 0/24, and then you can see gigabit 0/1 to 0/2, and then you can see VLAN 1. This VLAN 1 is not physically on the switch. So if you go to physical mode of this switch, right, you won't see VLAN 1 here. Now this is fast Ethernet 0/1, all the way to 0/24, right? So this 12 plus 12, 24. This gigabits 0/1 and gigabit 0/2. So where is the VLAN 1? you won't find it there. So the VLAN 1 on a layer 2 switch is a virtual interface. So it is for virtual configurations, right? So this VLAN 1 interface is where is the interface you will give an IP address to. So if I do configure terminal, right, and so I'm in the laptop, should, yeah. So you will see that anything I type on the switch will reflect here. So let me go back to the switch. So if I do interface VLAN 1, so access interface VLAN 1, this interface, and I do IP address 192, let's give it 192.168.10.253, then 255.255.255.0, right? So I've configured that interface with that IP address. So let's go back, let's go to the laptop, so that the same thing is reflecting here. So you configure, so you configure the switch with the laptop, right? So if we exit and we exit and do the same show IP interface brief, you now see that VLAN 1 now has this IP address, and because we use the no shutdown command, is now up. So if you want to manage this switch, you will use this IP address in PuTTY to gain access to the switch. So you will type in this IP address, then use SSH, then open. So once you open it, PuTTY's interface will show up, and this is PuTTY's interface. Why am I authenticating every now and then? No, my VPN is not on actually. What's going on with Google now? I'm opening images now and it's not open. Now wow. So this is PuTTY's interface, right? So it's like it's a CLI. So you now begin to configure the switch through PuTTY. PuTTY gives you remote access to that switch itself, right? So that's the second way. The third way is to use a serial connection type. The serial connection type, it works when your cable is plugged. So there's the GUI. You can, depending on the maker, you can open a Chrome tab and log into that IP address. So if I was using Chrome, we'll log into this, right? We'll log into this website, and then it will open up a GUI that we can configure stuff. But most times we have to use a CLI. So that's why we're using PuTTY. So PuTTY you can connect through, it can't go because it's a private IP. So that was expected. So so we can use IP address when we use SSH. We can use IP address. We can use serial. So serial has to do with the ports that the cable is connected to. So you go to device manager and you open ports. So that port that you connected the console cable on to the switch. Once you connect it, it will display a detail here, right? So it will display a detail that, oh, this port is connected to XYZ, oh, and this is the detail for that port. So you would take note of this number here, and that's what you will use to connect. Just type in that number from 3 and you connect through serial. So you don't need to use IP address. So that's another way. So all of them will bring you to that CLI page. Nene, does it make sense?
Yes, it does. Thank you.
Okay. So we are configuring the switch through Nene's laptop, right? So we can configure the name of the switch as Lagos branch switch. Okay. Okay. All right. I know what's going on. Ask me to do it from configure terminal from global executable. So Lagos branch switch one. So we are in. So what else do we need to configure in this switch? For now, nothing. So this is how you do it in the real world. Does it make sense? Are we all clear? I want everyone's feedback. Are we all clear? Gabriel, are you getting it? No.
No, I dey follow along. I follow along.
Okay, okay. So yeah, is everyone clear? If I'm not clear, please speak up, or I am here for you. I'm here for you. I'm here for you. So I think we're all clear, right? Okay then. Okay. I think we're all clear. So let me go back. So yes, we've configured the switch, the IP address, and so let's see if we can ping that IP address. Ping 192.168.10.25. So we all know why it's timed out at the first time, right? That's because of app address resolution protocol. So now it should work. So yeah, we have network connectivity, right? So yeah, this 10.12 should be 10.13. This should be 10.14. So 15. So let's connect these two laptops to the suite, to the access points. So first, let's give them IP addresses first. 10.16. 10.17. Should be 10.18. And this will be 10.19. So let's connect this to the access points. So it says WMP 300N is needed, or WPC 300N. So let's do that. We go to physical, we turn it off here, remove this module, then we add this WPC 300N module. We'll put it on, and we go back to wireless. So it should open now, click connect, then we should find our access point, then connect. It has a password. Password is Nene Ojidan, and we connect. So we are in. The same for the legal Chinasa. We put it off first. Put it off. Remove the module. Add the WPC module. Put it on. It's desktop. It's wireless. Then you connect. Wait for it to find the access point. It's the access point. You shared key. Then done. And you connect. Then we are in, right? So we've configured all the devices on the switch, right? So this is what you call a flat network. Everybody can reach everybody. So let's try and ping. Let's do it in simulation mode. So let's try and ping 192.168.10.17. Let's ping that. Just the switch. Now I explained last week. Nene, please unmute your mic. Step onto the dance floor. Tamara, you have a question.
I wasn't here last week, so I was wondering about the connection. Why we have some people connected to the access points and others to the switch.
Okay, very beautiful question. Let me see what I'm going to pick to answer. AZ3 Senpai, please can you answer a question?
I can't answer it. See, I'm about to hop out of this
meeting to go and join these people's configuration project thing. So my
Oh,
brain is tired today.
the mid semester project work, right?
Yes,
It's
yes, that's
it's
what I'm battling
okay.
today.
Let's see. So nominate who is going to explain.
Anybody, oh,
Nominate.
anybody that
Choose.
loves networking as much as you like it. Nominate.
I bet ask that Danny.
Uh, uh, let's see. So let's do Candy. Candy.
Why now? Why Danny?
Yes.
Can you answer our question?
I didn't hear you. So me, I don't understand networking. I'm not even going to lie to you.
But you were on the call last week, no? You were on the call last week, right?
Last week, no, I wasn't. To be honest, I wasn't.
You were not. Hey, God, I beg.
I
God, I
wasn't on
beg.
the call. I'm sorry. I had out of.
Okay.
Yeah.
Shinasa.
Hi, Bola.
Hi. How are you doing?
I'm okay, and you?
I'm good, though. So, do you want to answer the question?
Well, I don't know. Let me try. Basically, you said that we use access point to is a device that we use is a wireless device rather that we use to connect to a wired network. I think I don't know if that was what you said.
Yeah, but I said more than that. But yeah, you are there. Yeah. More.
Help me out.
Wow. Okay. Let's see who can help you out. CO. I don't. The question is, why are we using an access point in the network topology? Why are some laptops connected to the access point? Why? So that's the question. So COO, I don't know your full name. COO.
I was thinking the same thing as what Chinasa said, actually. So,
Yeah, but
so my opinion.
there's there's more to add now. Like I'm not sure Tamara understands just from what has been said.
Okay, so I remember you saying, well, I don't think I was listening to the end. I remember you saying that most PCs do not allow wireless connection. Yes, so we use wires to connect, we use cables to connect the PCs to the switch, but laptops allow for wireless connection. Hence, we can use wires to connect them, but we can also use like the access point to connect them using like an access point to the switch, wireless connection. Yeah.
Hmm. Thank you. We are building up. Thank you for that. Thank you for that. Nene.
I think you said the switch has like a limited interface, like it's not like it cannot carry over, because I mean, based on our setup here, it's 200, so it cannot carry up to that 200. So we are using the access point to connect to the wireless host. That's like the laptop. So like to reduce the load on the switch, something like that.
Hmm. Okay. Okay. That's cool. That's cool. Gabriel, your hands are raised.
Okay, I did not join last week class, but I don't know how I understand access point to operate. It Just like how Nayes said, due to the limitations of switches having limited ports, I learned that access point is used to connect devices in a particular zone area or particular location. So those devices that are connected to that access point will receive packets or traffic that has been assigned to that access point. Because I was watching a video about network chalk and David. So I was in my office. We have those access points. So I did discover that if I'm in this office area or this area that has this access point, I do get network connectivity. But if I leave that area and go to another area that has another access point, I'll have to be required to log in. So for that, how I understand access point to work, like just like a rough idea. So I don't know if it's what's also similar to how you explain access point to be. But that's my understanding of access point anyway.
Okay, that's cool. Um, let's get more yellow chili.
Why are you laughing? Okay, so the way I understand, you said why do we use access points, right?
Yeah.
Okay, so from everything you've explained, do you understand it is that without access points, it's only, you know, wired devices that will be able to connect. So the access points allow for, you know, devices that are wired, sorry, that are wireless to connect. So it means that, there'll be more um let me use the word that Mr. Victor likes to use, scalability. That means, there will be more use for, many more devices to be able to connect if there are access points. All right.
Yeah, thank you very much. We've all done well. Like I love the angles. Like that's very good. So an access point will typically let me show you a picture of an access point. If you've not watched the first video on YouTube, I would say we should watch it. Okay, because Tamara, you have your hands raised.
Yeah, okay. So it's not like I don't understand what the access point does. But I'm looking at the network and I'm thinking about the rationale behind the structure of the network. Why some are connected to the access point and then why some are directly connected to the switch. That's just what I'm asking. I'm trying to understand what you're trying to achieve. The structure is what I'm looking at.
Oh, okay, okay.
Yeah.
It makes sense now.
I was wondering why you asked for that.
No, that's
Okay, so this is just a rough topology, right? So the goal is not to it's not to achieve perfection in how the topology is. The goal is to use the topology to explain networking as much as we can. For example, now this topology that is here, I can use it to explain network security, how that this network is not secured enough. I said that in designing a network, it has to be redundant, it has to be scalable, it has to be secure, it has QoS. I can see a tutorial on how that this topology is not as secured as it should be. So we just felt like, okay, let's just like demonstrate how um a real world enterprise network might look like. In a real world setting, there are certain laptops that will not connect directly to the switch. They will connect to the access point to connect to the LAN. That's how it is. You know, some devices are directly connected to the switch, some have to connect to the access point. You know, so for example, now imagine we have two switches and we have 100 laptops. We would have to buy more switches just to contain the number of laptops we have now, because we have like roughly 24 ports. Or even if we have a switch that has 48 ports, we still have to buy 3 switches just to connect 100 laptops. Now, what if we have an access point that can take in 50 devices? So instead of overwhelming the switch with a lot of devices, because even this switch, we cannot plug 24 laptops on the switch. We still have to leave a port to connect to another switch, or leave a port to connect to a server or a router. So at most, we might only be able to even connect 15 laptops to the switch. So how are we going to manage our resources? We will need an access point. So certain laptops would have to connect to the access point. So does it make sense?
Yes, sir. Very, very clear, sir.
Tamara has disappeared. I think she just left. So when she comes back, someone can alert me, sure, so that I can ask her if she got the explanation. So yeah, so let's continue our simulation. So we know why the switch is broadcasting, right? We know why, right? Topway, why is the switch broadcasting?
Eric, Tamara is back. Ask her if you understood what you said.
Oh my God, Tamara, did you get my explanation?
Sorry, NEPA took the light, so my internet went off.
Oh,
I'm back.
what was the last thing you heard me say?
Okay, you were talking about having a lot of systems to connect to the switch.
Yeah.
But that's why you have to split it, you know,
Yeah.
for the wireless connection. That's where I stopped on the
So
system.
we might not be able to connect all the laptops to the switch. There are certain ports on the switch that we might have to dedicate to being connected to a router, or being connected to another switch, or a firewall, or a server. You know, so it must mean that for us to be able to manage the resources, why not we connect an access point? So an access point, you can connect an access point to the switch using a LAN cable. So an Ethernet cable, you can plug it to the access point, and then you plug it to the switch. So that access point will help us extend that network, so much so that laptops can connect to it. In fact, if you're in an organization and you want to use your phone to access resources in the LAN, you can't get an Ethernet port and then be looking for where the switch is to plug it directly to the switch. No. So you have to use your Wi-Fi on your phone to connect to the access point. So that's why we're just trying to like depict a real world scenario. So is it clear?
Yeah, that's very clear. Thank you.
Yeah. Okay. So Tokwa, you cannot escape my question. So why did the switch broadcast? So why did the switch broadcast?
Hold on. I don't know. I don't
You
know.
don't.
I would have to watch the video again. Now after
Okay.
you don't post on for YouTube, but they always grab am.
So you know what's the first one?
So maybe I didn't get your question.
So
How did you?
we
Okay.
were doing a simulation, right? So let me reset this simulation. So let me ping from this laptop. Let me ping from this laptop. So command prompt. Let's ping 192.168.10.60. So it generates a packet. So when the packet, because this legacy laptop is connected to the access point, so go to the access point first. Why did the message disappear? What's this now? Why did the message disappear? Sorry. Let's try another PC. Let's use this PC. Simulation. Let's pin again. 192.168.10.15. I can't even find this thing. What's wrong with Cisco packet trace? Uh, so let's just use this. Ping 192.168.10. So it generates a packet here, and then it goes to the oh, it is to itself. Ah, God, I beg. It pinged itself. Okay, so Control Z, Control C, ping 192.168.10.11. So it generates a new packet, send it to the switch. Now the switch sends a broadcast. Why? Why is the switch sending a broadcast? That's my question. Okay.
Oh.
Okay. So did you get the question now?
Yeah, I did with you. Yeah.
Yeah.
I guess.
You did with me. Soft.
The switch is looking for the boyfriend of the girl. And now the girl is calling the boyfriend's name, and the switch is like, who is Tokwe here? Nene is looking for Tokwe. Oh, yeah.
Why are you?
If you
Why
know
are
your,
you answering for him now?
no, I'm just using an example. If you know your so and so is looking for you.
Why are you helping him now? Oh.
Yeah, she don't answer now.
That's
Okay,
better.
so
Gabriel, please. Gabriel.
It's part of it.
It's part of it. Yeah.
Gabriel, okay.
What can I do?
So why is broadcasting?
Okay. Okay. According to me, I understand it too. According to me, I understand it too. when I think switches, depending on the layer, the kind of switch that is being used. I don't know whether they say whether switches operate on whether IP are being marked, something like that. So when you send the request, so it is like who has this IP address, who has this IP address. So it sends that request to all. I think is it all the ports. Then any so the devices that are connected to that port, they will receive their request. So if they are not the one, they will not reply back. But the device that is connected to the port of that switch that has that IP address will now say, okay, I am the one that has this IP address. Who's looking for me? They will now send the request back to the switch, and the switch will say, okay, oh, I have found who you are looking for. This is the person that is here, and connection successful. You get no loss and blah blah blah. That's what I understand it to be.
Tucker, please
I don't
unmute,
surprise Danny.
mute your mic. Gabriel, please mute your mic. So okay. Okay, nice one, Gabriel. Nene, please take the center stage.
I thought she has answered it.
Answer
Anyways.
it in your own way.
Anyways, I feel the reason why it is broadcasting is because the host or the device sending the packets has the IP address, but the device does not have the MAC address. So the device is sending like a broadcast message to ask them who has this IP address. Then
Which device is sending the broadcast message?
The one sending the packets now is looking for the MAC address to attach to the packet.
Are you sure about that? Are you sure about that?
I don't know again.
Okay. So let's see. Shinasa, let's see. We all know that this is in the part one, Sha. Like it is in the part one. I saw it in the video. Let's see. Shinasa.
Okay.
What do you have?
The switch is sending. Can you hear me?
Yeah, I can hear you.
Okay, the switch is sending the flood, should I say the flood message, because it hasn't linked the MAC destination, I guess, destination of the packet. So that's it. But once it learns it, it's not going to flood, it's just going to forward the packet directly to the PC.
Yeah. So yeah, so that is the answer. So let me break it down again. So every device has an app cache. It's called an app cache. ARPCCHE. So just to confirm that, do all end devices have an app cache? Yes. So the answer is yes. So Nene was right when she said that it could be that the device didn't know the destination MAC address, right? So I want to highlight that every end device. So your laptop has an app cache where it has the MAC addresses of other devices that's connected with. Just know that one and no peace. So your laptop, in fact, forget the switch first. Your laptop has a record of the MAC address of devices that's connected to. However, and this was where I wanted to blow Nene, right? Your laptop can know the MAC address of the end of the destination device, and the switch can still broadcast the message. So it is the switch that is doing the broadcast, not your laptop device, not the sender of the packet. It is the switch. I said it the last week that a layer 2 switch, emphasis on a layer 2 switch. A layer 2 switch does 3 core functions. It lengths, it forwards, and it floods. Don't forget it. LFF. That's the code. It lengths, it forwards, and it floods depending on the MAC, on its MAC address table. So every switch would have a MAC address table. The command to view a switch's MAC address table is the show MAC address table command. So I ran the command not too long. So you go to privilege exec mode and you use the command show MAC address table. So it will see it has length all these MAC addresses. Now, if I open this suite that we've not touched at all, you will see that enable show MAC at table. So that it does not have anything in its MAC address table, right? So that's because it has not learned the devices connected to it. So a switch uses its MAC address table to learn the devices connected to it. So you would see that on the switch on fast Ethernet 0/7, this MAC address, this device, this MAC address is connected to it. So let's trace 0/7, right? Options, preference, show ports. So let's trace FA 0/7. So one of them is /7. Now this /8. This should be /4. This is /10. /5. This /13. Dear God, I beg. This /7. This /8. Let's just check for it since it's also connected. So okay, that it hasn't length for it. So let's check for /1 then. First /1/1. This /7 that we were looking for. So let's go back to the switch. /7 has, so on the switch's MAC address table, right? The device connected to it on fast Ethernet 0/7 has this MAC address. Don't forget that we've configured this device with an IP address, right? See, 192.10.13. So what is its MAC address? Its MAC address is 0000.0651.1380. So the switch doesn't look at the IP address, it looks at the MAC address and it learns that MAC address. How does it learn it? It will learn it first when it first broadcasts. A switch learns by broadcasting. So if you send a packet to a switch and the switch does not have the destination MAC address on its table, it will flood the packet. So the device that has that MAC address, only that device would respond. So when that device responds, the switch will now learn the MAC address of that device and know that, oh, on this interface, so this device with this MAC address is attached to me. So it will update its MAC address table. So if you check, this has a MAC address of what is that MAC address again? Go to fast internet. So it ends with 1380, right? So let's go to the switches table on 0/7. See 1380. So it has learned the MAC address of that particular device. So if we look at all the devices here, right? It has learned the one for 0/6. So if we ping this device with 0/6, it won't flood. So let's ping the device with 0/6. The device with 0/6 is fit TOG. Where's that device with 0/6? So I think it should be 0/2. This is 0/9. This is 0/5. So Funke is 0/6. So let's check Funke's IP address. IP address is 10.18. So don't forget that the switch has learned that MAC of Funke. So if we ping it here, there will be no flooding. So let us try that and see. Desktop, command prompt, ping. Funke is 10.18. So you see that there will be no flooding. It sends to the switch. The switch sends directly to Funke. Why is it flooding? Why are you flooding, man? Come on. So something is going on that is wrong, but let's see. So it has learned it now. So it should forward it directly to it. Okay. So the subsequent pings will be forwarded. It will be forwarded. There's no flooding. The next ping. So I think it sent a broadcast because of a formal ping that we have done. It happens with this simulation mode a lot. So this is a different packet. This is a BPDU packet. That's why it's in pink. It's a different kind of packet. So the one from KND is just coming now. So that is in green. So it will forward it. It won't flood. So a switch forwards when it does not know the destination MAC address. It floods, sorry, when it does not know the destination MAC address. And then when it floods, it now learns that MAC address. So subsequent times, it will now forward because it has learned the MAC address. So is it clear? Nene, is it clear? I want to hear.
It is. It's clear.
Okay. Who's raising up the hand? Which that you can talk. You can talk.
I have one question. No, I get one question.
Okay.
Like, about what I know before, like, I'm trying to have clarity on the MAC
Hello.
address. Or,
Hello.
eh?
I could not
Are you
hear
hearing
you.
me? Are you hearing me?
See,
Are you hearing me?
hold on first. Hold on.
Okay.
Mute your mic. So I was telling us that the pink message was a BPDU message. So this BPDU is a spanning tree protocol message. Very important message. It's called Bridge Protocol Data Unit. So a switch sends that packet every 30 seconds, if I'm right, if I remember correctly. After how many seconds? No, I think 50 seconds. But let me check. After how many seconds does a switch send a BPD? I think it should be 50. Yeah. Hello BPD. 2 seconds. Yeah, every 2 seconds, every 15 seconds, every 20 seconds. Okay. Given 35 seconds. Yeah, around 30 seconds. That's what I know. Yeah, around that 30 seconds. So it sends hello BPDU every 2 seconds. Then it sends a final BPDU message after 30 something seconds. Okay, so and then yeah, I'm mixing it up. Don't mind me. So yes. So a switch will always send that to learn about the network topology. That's what the switch uses to learn about a network topology. So, but that's an advanced networking gist. So, I just wanted to show us that was why there was a broadcast on that one. It will always broadcast because it's trying to learn the topology. So there's a reason why there's no response from all these guys. Now, if I connect a switch, see something very interesting. If I connect a switch to this other switch, what will happen is this other switch will respond to the BPD, should respond. So let's just see. So this switch will respond. You see, it's going to respond with yes. So it will respond with that. Let me remove this. So a switch uses the BPDU to learn the topology, to know if other switches are connected to it. That's how a switch learns if another switch is connected to it through that BPDU packet. Let's reset this. So it sends it back. So only the switch will respond. Only the switch will respond. So let me not bust with that, but that is how a switch learns the network topology. So a switch learns, that's a spanning tree protocol gist. So the switch learns a MAC address. It learns the topology. Yeah. So there's a lot of learning that switch does. Okay. So Gabriel, yes. Sorry for cutting you short with that one.
No wahala, my oga. Are you hearing me clearly at the moment?
Yeah.
Okay, so I'm trying to I have a question I want to ask. So now I learned that a switch learns the MAC address of the devices which are connected to it. Now, if a device want to communicate to another device, they do so via the IP address rather than MAC address, right? And the ARP cache, I think it has the IP address. It has the IP address that has been assigned to the MAC address. But in a situation whereby, let's say, if two devices, they switch about the length their MAC address and also the IP address that is associated to those devices based on the ARP table. If it was now swapped, if the two IP address was now swapped, and you now try to run the ping or stuff, what will happen since now it has been swapped? Will the switch now have to now unlearn and now relearn the new IP that has been assigned to the MAC since it recognizes it via the MAC address? I don't know if you get my question.
Yeah, I do. So you can mute your mic. So let me show you something about the app. It clears up. I think I can't remember after how many seconds or after how many minutes. So the time an R table entry remains valid varies depending on the operating system and network configuration, but it's typically 2 to 20 minutes. So for a Windows system, it's usually 2 minutes default. So it means that even though you have done app and then you've mapped a MAC address to a particular IP address, that mapping will only last for a particular time. So it will reset again. So that answers your last question, right, Gabriel?
Yeah, it does.
Yeah.
So
So
it's clears and starts
yes,
fresh.
it does.
But I have a question, another question. Now, this clearing of the IP address that has been mapped to the MAC address, is it because it's based on DHCP protocol?
No,
Because probably or
no, it's not. It's
okay,
not
so even
based.
if I'm using a static IP address, it still
Yes,
clears it.
yes.
Okay.
It still does. And let me tell you that in a network, I can tell you that the MAC address is even more important. If we are going to place importance, so let me show you something. Can an end device send a packet to another end device without knowing the IP? Let's The answer is yes, and I'm not so surprised. You see, it tells you an end device can send a packet to another device even without knowing its IP address. It's probably actually through the use of MAC address and an app protocol. You see, so while IP addresses are crucial for routing data across networks, within a local network, devices primarily communicate using MAC addresses. So MAC address is the most important. Now, if I do the reverse and I say without knowing the MAC address, it should tell me no, except it learns the MAC address. It has to learn no. An end device cannot reliably send a packet to another end device without knowing its MAC address. So in a network, MAC address is very important. In fact, make the destination device no get IP. Find a way to drop that packet device by virtue of MAC address. Long as it knows the MAC address, that is enough. It's called NIC to NIC communication. It's called NIC to NIC communication. So even when you have IP address, you must know the MAC address. It's so important. It's so important. So the MAC address is, in my opinion, the most important address in a network. So did I answer your question?
Both my brain, guy. You don't boast my head.
Oh God! Wait till this.
Anyway, you answered my question.
Yeah, so good. I said Nick to Nick. Hey, Tamara, I said Nick. Where you see your own now. Oh. You dey put images inside my head. Images where I don't want to think. Eh? Why? Okay, so I think we'll stop here. So we'll stop here for today, so that we don't have information overload. But was the class worth it? Was it worth the time?
Your
Yes.
food will not burn. Thank you.
I learned a lot today.
So, wow. So we have our next class.
Daniel, see yourself.
Should have our next class tomorrow by 8 p.m. same time. 8 p.m. tomorrow. We'll continue from there. So
I'll be there, sir.
be there no matter what. So yeah, I think that should be all for tonight. Let's have a wonderful night rest and a wonderful Sunday.
And you